To develop and manufacture the low-cost guided advanced tactical rocket system, also known as Gator. Gator is an affordable 70mm guided rocket with a lightweight design that is compatible with existing 2.75-inch 70mm launcher hardware. The system features lock-on before or after launch capabilities, as well as autonomous or remote laser designation. These features enable the rocket to be deployed against targets at ranges of more than 8 kilometers from fixed and rotary wing aircraft.
8, 9.
Gator supports integration on a full range of attack platforms, ranging from attack reconnaissance helicopters with critical weight restrictions to heavy attack platforms requiring many stowed kills per sortie.
2, 1.
Gator employs a semi-active laser guidance package, employing acquisition tracking and guidance algorithms to achieve 1 meter accuracy against both stationary and moving targets.
11.
Gator minimizes collateral damage while providing standoff deployment against a wide array of target sets. In its tactical configuration, the rocket utilizes enhanced insensitive munitions technologies, including an IM rocket motor and a family of IM warheads to include blast fragmentation and penetration. Gator provides excellent terminal energy to penetrate hardened targets, as well as moving and maneuvering targets. Penetration of typical urban structures can be achieved at ranges in excess of 6 kilometers. The system's semi-active laser seeker guides the rockets to less than 1 meter accuracy. ATK has proven Gator's capabilities through a series of tests at numerous ranges and also from airborne attack platforms. Recently, Gator was fired from an armed Black Hawk and the OH-58D Kiowa Warrior, using a lock-on before launch method to engage an off-boresight target at ranges exceeding 5 kilometers. Through a series of tests, ATK has validated flight worthiness, safe separation launch, as well as autonomous and remote laser-designated guided flight. Gator is an affordable weapon system that fills the gap between larger, more expensive guided missiles and the current family of unguided rockets. Gator combines combat-proven performance in rocket propulsion, warheads, and laser-guided seeker technologies to deliver a low collateral damage solution, effective against the modern enemy.
Okay, that's it.
The Advanced Precision Kill Weapon System, or APKWS, is a guided 2.75-inch rocket that uses semi-active laser guidance technology to strike soft and lightly armored targets in built-up and confined areas. APKWS can easily convert an unguided Hydra rocket into a guided rocket without altering the effectiveness of the warhead and fuse. It is a plug-and-play, point-and-shoot system that requires no modification to the aircraft or launcher. The system consists of 4 components: the M423 fuse, the M151 warhead, the MK66 Mod 4 rocket motor, and the WGU-59B guidance section. BAE Systems developed an innovative mid-body design for APKWS. The key to the design is the placement of the Distributed Aperture Semi-Active Laser Seeker, or DASL's, aperture domes on each of the guidance section wings. In the retracted position, the optics are stored inside the guidance section and are protected by special wing slot seals. This configuration protects the guidance optics from the effects of environmental conditions and damage from adjacent rocket fire. The guidance system uses the same laser designator as the Hellfire missile. For the pilot, laser targeting procedures and armament control remain unchanged from those of current laser-guided weapons. The weapon can be guided remotely through a targeting team on the ground, a buddy aircraft, or autonomously through the platform's onboard target designation system. Conversion of an unguided rocket into an APKWS guided rocket is simple. The unguided rocket is placed into a fixture where the fuse and warhead are removed from the rocket motor using a strap wrench. Next, the guidance unit is screwed into the rocket motor and the warhead and fuse are screwed into the guidance section to complete the conversion. Before inserting the weapon into the launcher, a pulse repetition frequency code that matches the one of the designating laser must be dialed into APKWS through the laser switch assemblies. Next, the on-off switch is placed into the on position. Having completed these procedures, the APKWS-equipped rocket is now ready to be loaded into the launcher. Due to its mid-body design and laser seeker aperture placement, APKWS is a lock-on after-launch weapon. The most obvious advantage of this design was revealed during adjacent rocket fire testing. The testing consisted of 6 APKWS-equipped inert rockets placed into the tubes surrounding an unguided rocket. The mid-body guidance sections are fully enclosed in the launcher and are protected from the fire, smoke, and debris from the fired rocket in the center. Upon removal from the launcher, one can see how the APKWS guided rocket's optics are protected from the effects of adjacent rocket fire. Within 1 second after launch, the battery energizes the electronics in the guidance section. The wings deploy, and the trailing edges, called flaperons, de-roll and stabilize the rocket. Following de-roll, the 4 sensor aperture domes work together to create a sight picture with a 40-degree field of regard. Seeker optics then lock onto the laser energy that has been placed on the target, and guidance begins. In testing, the sensors acquired laser target data as far away as 14 kilometers, well beyond the range of the rocket motor. During flight, the seeker electronics interpret the intensity of the laser energy and determine the angle to the target. This information is sent to the guidance system. The proportional navigation software maintains the closure angle for stationary and moving targets. Simultaneously, the internal measurement unit, or IMU, senses pitch, roll, and yaw. The autopilot uses the IMU and seeker data to calculate flaperon positions. This data is sent to the control actuation system, which in turn controls the flaperons. The result is precision flight to the target. APKWS fills the weapons gap that exists by providing a precision-guided rocket that will eliminate soft and light armored targets. It is not intended to replace the current requirement for unguided rockets used for area suppression, illumination, obscuration, or marking. It's also not designed to replace the need for a high-yield anti-armor weapon such as the Hellfire missile. In U.S. Marine Corps testing, the performance of APKWS has proven to be outstanding. Since testing began in 2002, APKWS has hit its target 68 times within the 2-meter requirement at an average of 0.44 meters or 17 inches from the laser spot, whether shooting at multiple stationary targets or high-speed moving targets. APKWS has demonstrated that it is the right weapon for the warfighter in today's battlefield environments.